So because of that, I think, and I also want to give my TA, opportunity to also do some grading too. So make use of the opportunity of new assignment posted for the week. Okay, so I want to go into chapter 6. I want to start a new chapter, but you know what? Before we go here, we still have some outstanding, okay, from the last material, and because of that, our four of us to review the last material, where we left off in the last material. I remember we left off at covariance, the correlation and the like. So I quickly want to have a review on that before starting this material. Okay, so this is the last material. Of course, I'm actually quickly, I think I remember I stopped here. But this is what I want you to see, okay? Expectation, the whole thing is going to start from expectation of the product. Expectation of the product of X and Y. Expectation of the product of X and Y, okay? Expectation of the product of X and Y, if, for continuous, I'm actually going to have that integral this f of x, y, the x, the y, okay? And of course, situation where maybe I have A to B, C to D, I'm actually trying to say x lie between A and B, y lie between C and D. Now, this is the expectation of a product. Expectation of a product does not directly has meaning in statistical analysis, okay? But you know what? There's something that has, if you take a look at this, if I want to talk about covariance now, okay? Covariance of X and Y, okay? Covariance of X and Y. I actually need, this guy is going to, expectation of the product will be with part of the formula. So the covariance of X, Y is the expectation of X minus mu of S, okay, Y minus mu of Y, okay? Now, this is the covariance, okay, of X and Y, okay? I can define this covariance for discrete, I can define it for continuous, okay? So when I expand this, we can also summarize covariance of XY as the expectation of the product minus expectation of S, expectation of Y. Please pay attention. You can see, for instance, if I give you f of xy, and I ask you to get the covariance of xy, you need to first get the expectation of the product. Then you also need to get the expectation of S, expectation of Y. Don't forget the expectation of S. I'm actually going to be that x f of S ds. Okay, the expectation of Y is going to be that y f of y, the y. Okay, and don't forget the f of S can be derived from the f of xy. Okay, also recall that f of S equal integral f of xy, the y, okay, c to d, and f of y equal integral f of xy ds, okay, from a to b. Okay, you know, if I give you a question on f of xy, I can ask you a lot of questions. A lot of questions. Okay, now, when you take a look at this is the covariance. Now, let me talk about this. When I say covariance, what do I mean by covariance of x and y? You know, the covariance, I actually want to have a measure of how variable x and y varies together. I want to see whether as one increases, what will happen to the other one. Is also going to increase or move in different direction. Now, when I talk about covariance, the covariance is not bounded. The covariance value is a real number. It's not bounded. Okay, because of that, the covariance cannot be used to cannot be used as a measure of the strength of the relationship. If you want to know the strength of the relationship, whether it is weak, strong, perfect, or zero, you cannot use covariance to determine the strength. But what the covariance is going to tell you, the covariance can give you the direction. Direction in terms of whether it is positive or it is negative, okay? But the covariance cannot actually talk about the strength of the relationship in terms of weak, strong, and whether it is perfect. Now, another thing I want you to see, if the covariance is that, then if I want to have a measure of the strength, then I need a correlation, okay? I need a correlation, okay? So, therefore, if I want to get correlation, I need to standardize covariance, okay? So, correlation is a standardized covariance, okay? So, now the correlation, okay, the correlation xy is going to be covariance xy, okay, divided by the square root of the variance of s, the variance of y. Okay, look at that. Now, covariance of xy, you can get that from here. Okay, and here you need to get expectation of the product, expectation of s, expectation of y. Okay, if I wanted to get the correlation, the covariance divided by the square root of that. And what is the variance of s? The variance of s is expected value of s squared, expected value of s all squared. What is the variance of y? Okay, expectation of y squared minus expectation of y all squared. Look at that. Okay, and you know what? What is the expectation of s squared is going to be s squared f of s ds a to b. What is the expectation of y squared? It's going to be c d y squared f of y dy. Okay, so there's a lot of formula here. Now, I quickly want to show you. This is the expectation of the product. But let me tell you this. Situation where if x and y are independent, okay, if x and y are independent, okay, we actually going to have this guy will be equal to 0. Okay, okay, situation, let me write it there. So, situation. So, if x and y are independent, okay, so if x and y are independent, okay, okay, the covariance of xy equal to 0. And what was the formula of the covariance the other time? Is this guy. Okay, in that regard, where this guy equal to 0, that implies expectation of the product will be expectation of s, expectation of y. That is a situation where x and y are independent. The covariance becomes 0. The expectation of the product becomes the product of the marginal means. Now, I want to walk you through some example quickly right now. Okay, I want to walk you through some example quickly. Now, if you take a look at, let me start from this theorem. If you take a look at this theorem, this is what I just, when x and y are independent, those of you over there, can you see this? Okay, when x and y are independent, okay, the variance, if you take a look at what I'm trying to do here, okay, I'm talking about the variance of as plus by. Okay, now the variance of as plus by, another way to write that is to write sigma squared ax plus by, which is going to be equal to the variance of as plus the variance of by. Okay, a and b are constants. I'm actually going to have a squared variance of s, b squared variance of y. If I want to rewrite that, I'm actually going to write a squared sigma square s, b squared sigma square y. Look at that. So this occurs because we said here, x and y are independent. Okay, you can see there's no covariance. Okay, we only have variance of that. When x and y are independent, that is exactly what I'm trying to say here. And let me tell you this. Whether you have minus or you have a plus, it's going to be the same expression. Because situation where you have a minus, please pay attention now. Okay? Pay attention. If you don't understand, ask me question. Okay? Situation where I have AS minus BY. Okay? I'm still going to have the variance of AS plus the variance of minus BY. Mathematically speaking, plus minus, that's a minus, right? Now, I'm still going to have A squared, variance of S, plus negative B squared, variance of Y. What do I have? A squared, variance of S, B squared, variance of Y, so which is A squared, sigma square S, B squared, sigma square Y. You can see this and this, they're going to be the same. Whether for negative or for plus, they're going to be the same. This is a situation where X and Y are independent. What if in a situation where they are not independent? Okay, I want to consider a situation now where X and Y are not independent. Please pay attention. Okay, if S and Y are not independent, if they are not independent, okay, what am I going to have for this? If they are not independent, the variance of AS plus BY is going to be variance of AS, variance of BY, plus two covariance AB, okay, AB covariance XY. So here, this is going to be A squared variance of S, B squared variance of Y, plus 2AB covariance XY. This is a situation where they are not independent. You're actually going to have covariance. Now, if I want to have the one for negative, the variance of AS minus BY in that regard is going to be A squared, variance of S, plus B squared, variance of Y, minus 2AB covariance XY. Now, when S and Y are not independent, if I have a plus 2AB covariance here for the plus 1, I'm going to have minus 2AB covariance for the minus 1. But situation where S and Y are independent, they're actually going to be the same. Okay, that's exactly what I mean. And you know what? I can generalize, okay, instead of, I can generalize beyond A and B. I can generalize beyond A and B, okay? Now, if I want to generalize beyond A and B, now, if X1, X2, until I get to Xn are independent, okay, are independent, so the variance, now, the variance of A1, X1 plus B2, X2, blah, 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 until I get to AN, until I get to, I'm using A. Did I use A? Yeah, I'm using A. Okay, until I get to ANXN, which is the same thing as sigma squared, AX1 plus A2 that until I get to ASN. So this is going to be, I'm actually going to have A1 squared, sigma 1 squared, A2 squared, sigma 2 squared, until I get to AN squared, sigma n squared. So that's what I'm going to have for general 1. This is what you're seeing here right now. This is a situation where X1, X2 are independent. Now, this is an example. If I want to have an example, okay, if X and Y are random variable with the variances given at that, the covariance given as -2, find the variance of the random variable, this guy. Okay, if I want to find the variance of this guy, please pay attention, okay? Please pay attention, okay? I think it's getting warm, so. Now, if I want to get this guy now, okay, what I'm going to do, okay, so, now, you're giving z to be 3x minus 4y plus 8. The question asks you, maybe to find the variance, I want to find the variance of z, mean I want to find the variance of 3x minus 4y plus 8. Now, let me tell you this. If I want to figure this out, this is a constant. This is the same as variance of 3x minus 4y. Because the variance of a constant is actually going to be 0. Now, here, I'm right here. I'm here now. If you compare, it means my A is 3, my B is that. I'm actually using this to figure it out. Now, that is if I'm assuming, I can only use this if I'm assuming X and Y are independent. Otherwise, I'm actually going to use this guy when they are not independent. But how am I going to know whether they are independent or they are not independent then if this guy is given? If the covariance, another way to write a covariance is this, sigma xy. But if you take a look at the question, the covariance is given to be -2. Take a look at that. When the covariance is not 0, when the covariance is either a negative or a positive, then they are trying to tell you X and Y are not independent. So what you're going to use here now, so I'm actually, here, I'm actually going to have, 3 squared variance of X plus -4 squared variance of Y, minus, don't forget, when I've considered the -1, the -1, when there's a covariance, I'm going to have a -2AB covariance XY. What is my AB? If you take a look at that now, my AB, if you take a look at what I have up to this junction, if I want to figure, now I've already put that here. That is 20. How do I get 24? I got 24 by saying 2 times 3 times 4, which is 2AB. 2AB, AB, the constant, the 2 constant, That's how I got the 24, So I got 24 sigma xy. Then I'm now going to plug in the value they gave me for sigma xy, Then I'm going to plug in what they gave me for the variances initially. Then this is the result. That's 130, Now, I want to move right now. This is covariance. I told you the other time. This is covariance. I think I'm going to be projecting both sides now. Please pay attention. I need you to pay attention. If you don't understand, just ask me a question, You ready? If you don't understand, ask me a question, Now, this is the covariance. Now, let me tell you this. If I want to find covariance when X and Y are discrete, I'm going to use this guy. If I want to find covariance when X and Y are continuous, I'm actually going to use that guy. Now, I want us to take a look at something. Of course, I've given you the covariance of XY is defined as this. The mean of X is expected value of X. The mean of Y is expected value of Y. This is just a proof, to show that, that equal to that. I'm not going to ask you about that proof, but just to show that that equal to that. But you know what? I want